Good morning, everyone. The topic of today's lecture is gases. Gas is a state of matter in which the matter particles, either atoms or molecules, are not bound to each other. They are far apart and they move in random directions. They are not bound because the average kinetic energy of the particles is greater than the potential energy of any intermolecular bond. This makes gas different from the other states of matter like liquids and solids, in which the intermolecular bond between the particles is stronger than the kinetic energy of the particles. You can imagine gas particles like tiny balls flying freely in space, such as in this figure. In order to understand gas behavior in chemical reactions, it is important to understand their physical properties, namely temperature, pressure, volume, and density. The temperature of a gas is related to the average kinetic energy of the gas particles. The faster the gas particles move, the higher its measured temperature is. On the other hand, when the gas slows down, its temperature drops. For most gases, when the gas particles slow down enough, they could stick together and condense into liquid. But helium gas is special because its particles can go so low in energy it almost stops moving. When this happens, it could approach the lowest temperature possible, absolute zero. Gas temperature is expressed in units of degree Celsius, degree Fahrenheit, and Kelvin, and it can be measured with instruments such as mercury thermometer and thermocouple. Next, gas pressure describes the force applied by the gas over a surface. When a gas particle hits a wall surface, it bounces back and changes direction and applies a force on the surface. The force applied by one gas particle is very tiny, but the collective action of many gas particles hitting that surface many times becomes a pressure that we can measure. We measure gas pressure in units of Pascal, atm, bar, torr, millimeter mercury, and others, with instruments such as barometer and manometer. A unique property of gases is they fill the whole volume of a closed container. A closed container is like a water bottle with the cap closed. If we inject a closed container with some amount of gas, the gas will expand until the volume of the gas is exactly equal to the volume of the container. Furthermore, if we take the mass of the gas inside the container divided by this volume, we get density. Density is mass over volume. In the next section, we will discuss how these quantities relate to each other through a series of gas laws.